Hi and welcome to part 6.5 of our Learn to Program with C tutorial series. If you're wondering why the layout's completely changed, it's because I'm coming back in time to do a point 5 because there's something I wanted to talk about that is important. You don't need to use it in any of the next episodes, but it's important nonetheless. So what it is something called a switch statement, and this is an alternative to lots of branching if statements in a row. So let me show you what I mean. So say you had something like a character variable called input, and maybe we get that from the user or something like that, but let's just give it a value for now. Like what we might have done before and what we did in the last episode with our if statements, we would say if input equals a, then we do take some action, and then we might say else if input equals b, we do something else. And you can imagine this goes on for a long time. Else if, and it becomes quite tiring, we're writing out this, and also it's just not very clear. So the switch statement came about to kind of address this particular use case where you're always checking the same input for input against different values, and it kind of creates an easier or more readable way for that. It also has some other properties which are quite useful, but let's look at what a switch statement equivalent of what we've just seen would look like. We use the keyword switch, and then we put the variable that we're switching on inside the brackets. So we're switching on input. Now, what we have is a number of case statements as children of this switch. So we would say case A, and then a colon, and then we can put all of our statements in here after the case, and when we finish with that particular case we put break, and then that breaks out followed by a semicolon, and then that breaks out of the switch statement. So we'd have then case B colon, put our statements, break, and of course at the end of all that we've got our closing brace for that. But as you can see, this is kind of a little bit more readable than having it say if input equals this, if input equals that. So let's just have a quick look at an example of that, and then we'll explore a little bit more about the switch statement. But it's quite simple, so this will be quite a short video. So this is going to be quite straightforward. We've got a file called hello-switch.c and a make file that's got a default init for hello switch, so we can compile it. We're going to declare an integer called c, which is going to store the integer value of a character that we read. Then we're going to get a character from standard input, so from the command line. I suppose we should probably write enter character. And I'm not going to print a new line because I want them to see the kind of colon there and then enter their character there. After they've entered the character, I'm going to write a new line, and then we're going to switch on the character that they entered. So switch in the brackets takes a variable that is then evaluated, and then this variable is going to be compared against each of the case statements. So we can say if the character is A, then we have a case and a break. I like to lay it out like this. There's different ways people lay out switch statements. This is how I like to do it, because I like to capture between the case and the break all of the statements that are relevant to that particular case. So we could then print out, you entered A. Something, I know that's mundane, but let's just do it like that. You entered B. Now the great thing about a switch statement, or the very useful thing, is you can have what's called a default, which is what will happen if neither of those cases match. This is the same as having an else at the end of your sequence of if-then statements. So it's like a catch-all. So we could say you entered, or invalid character, let's say, So let us compile that and run it. And we'll enter a character, we'll enter A, you entered A, try again, enter a character, B, you entered B, nice, it all works. Enter a character, G, invalid character. So this is functionally equivalent then to the following sequence. If C equals A, then we print U entered A, else if C equals B, print U equals B, else print invalid character. So these two things are functionally equivalent. They do exactly the same thing. And you can test that out and see that they'll do exactly the same thing. In fact, I can just remove, if I remove this switch code, we can obviously see that they do the same thing. I'll just recompile it, run it again, and do the same thing. You entered A, you entered B, invalid character. So it's just a different way to write that sequence, a way that's perhaps a little bit more readable. So that is a switch statement, and its form is switch variable, where we pass in a variable, and then for each case statement we need to have a value that is of the same variable type as the variable, or that can be directly compared to it. So we might say A, for example. It has to be a value because it's being compared against this variable. Then we have that, and we put a break where we want to end this particular case. And this, at the end of where we state this case, there is a colon. So we do that, and we put all of our cases in here. Let's put another one, B, have our statements, and then break. And then if we want, we don't have to, we can put in a default case. And the statements for the default case where none of those match. And then we break. Once we've done all of our cases and our default, we then close it off. So that is the switch statement. It's quite straightforward. Using switch statements instead of if statements allows you to do something which an if statement can't do, which is, well, you could, but you'd have to use more elaborate mechanisms. Now, which is called fall through. And let me illustrate this. So what we can do is we can say switch variable again. And when we've got our case statement, we put our statements below that we want to execute. And if we don't put break, what happens? Well, let me tell you what happens. If we don't put break, execution actually continues into the next case statement, and execution will actually continue until it sees a break. So if we put a break at the end of this case statement, then what will happen is when we reach case A, we'll execute this statement and we'll fall through into case B, or whatever case is below it, and we'll execute the statements of case B and then we'll break. Whereas if we just call it with case B, if we match just directly with case B, we execute this and then we break. So that's the thing with a switch statement. It will fall through, which allows you to do some quite useful things, because that means we can, if we want to, whenever we see A, if we want to execute these statements and these statements, it means we don't have to put them in here and then repeat them in here when these are statements that we only want to do for B. Let's show a quick example of that to make it clear. Right, so switch fall through. We're going to have an integer called C, and we're going to get a character from standard input. So we better say enter a character, and then we're going to print a new line after that. Then what we're going to do is we're going to switch on C. We're going to have our, for case A, just to illustrate this, we're going to print out, actually we're going to put string, because we don't need any formatting. And we're going to say, we're just going to print stuff for A. And we're not going to put a break statement. We're just going to have another case below it. And we're going to have stuff for B here. We're going to have a break there, and then we're going to have a default
default case, and we're going to put stuff for everything else. And that is it. Let's compile that and run it. So now, when we enter A, we reach this statement, so we print stuff for A. There's no break, so we fall through into the case below. It's as if that just wasn't there at all, that line, that case line, and we just carry on going down. So we print out stuff for B, we do the stuff for B, then we hit the break, and we break out of the switch statement. Let's run it again with B. Of course, in this case, we just print stuff for B, because we hit this case, print out this, and then we just break. And of course, anything else is going to get us the stuff for everything else as normal. So that's a useful feature of a switch statement.
So that's the switch statement. As you can see, it's pretty simple and it doesn't really need any further explanation. It's just useful as an alternative when you've got lots of branching if-then statements, or when you have an example or a piece of code where you want to fall through, where you want to reduce duplication essentially, and you might be wondering why you might use this. But once you know about this, you'll be programming and you'll be thinking of how to do something, and this will just seem appropriate. You'll just think, oh yeah, actually a switch would work better in that case. You'll just kind of know. But now you've seen it, you know what it is, and you know how to use it. Alright, I'll see you next time for more adventures in C.